Hey guys, welcome back to the channel and another video on the PrintNC. Today I'm going to be explaining how I built my Z plate out of aluminum using generic hand tools and simple techniques. This is going to be one way you could build a kind of modified V2.0 Z plate. This is my lower X roller instead of the L that other people use. And I've got a slightly longer Z axis and I've changed a few things, but the techniques shown here could be applied to, I believe, basically all builds so far. And I hope it's somewhat useful if you want to build your first Z plate out of aluminum. So I printed off a drawing of the Z plate and then modified some of the distances. I'm using a 3/8 by 6 inch longer than required aluminum plate, a speed square, a hacksaw, and then a drill and drill press. So I measured out 287.8 millimeters from the good side of the plate and marked it with a scribe and used the speed square to mark a square straight line that the hacksaw will follow. So now I'm using my thumb beside the blade to get it started and a few light pushes to get a notch in, and then I can really start to lay into it. This is just aluminum, so it's not nearly as hard as trying to cut through steel, and it's good to also put most of the force through pushing because the teeth are oriented in a single direction and pulling back doesn't really do much and just bend stuff over. So here I'm also switching to a lower pitch tooth, so lower teeth per inch. The cut finish isn't going to be as good, but I'm going to move through the material faster. It doesn't really matter too much. This end's not going to be, it's going to be the bottom end, kind of just free floating, so the surface finish in this end doesn't matter so much. At some point too, I'm going to be moving to a ball screw versus a T8 lead screw, and I'm going to use the PrintNC to make a Z plate more suited towards that, and probably similar to or using Logan's narrow Z plate. Keep in mind too, because the left part of the aluminum is the aluminum I'm going to be using and the part that I want to be exactly 2-dimension, I'm accounting for the width of cut from the blade by having the left face of the saw blade line up directly with that line I scribed. So I'm having that extra little bit of width of cut cutting into the excess material, so the piece that I cut is going to be as close as I can cut straight to the dimension that I scribed. So skipping through most of the cut, I'm now switching to the opposite side because we're getting so far through the material that the aluminum is basically hitting the top of the C of the hacksaw. And I'm starting the cut the same way as I did before, using my thumb to steady the blade so it doesn't walk back and forth, get a little bit of a notch, and then I can use both hands on the saw blade without it jumping out as easily from that notch that I started. And now I'm just taking down the sharp edges using a file. Files are similar to the hacksaw, where you want to push and not pull, because the teeth are oriented in a forward manner, and pulling them back just rounds the teeth off, dulls them. The cut didn't come out quite as straight as I would like because I was not paying too close attention following that line, but it's merely cosmetic and I'll be replacing the plate at some point anyway. So now I'm starting to measure and scribe all of the locations for the holes. Right now I'm just marking or scribing a center line down the center that I can then measure off of to the left and to the right to make sure that all the holes are kind of symmetrical about the center. And I'm using the top clean edge to reference the holes in the vertical dimension. So one cool thing with this speed square that I'm using here is you can adjust how much that the flat ruler sticks out, so you can use the butt end, line it up to a scribe mark with the 90-degree portion butted up against the material you are using, and run that up and down always referencing the exact same distance as long as the side you're touching is square and flat. Now, an easy way to save a lot of time through this stage of the process is just print off a scale drawing of the hole pattern for the Z plate, overlay that piece of paper on the piece of metal you're trying to cut out, and then center punch through all the center marks of those holes into the metal so that you can then get straight to drilling. I didn't go through that method here because I think my plate's a little bit longer than a piece of paper, and I wanted to be extra sure that all the holes were as precise as possible and didn't want to make any mistakes there. But I took a lot of extra time doing it. After all the holes were center punched, I moved on to pre-drilling with a 3mm drill bit. All this could be done with just a regular drill rather than a drill press, but you get peace of mind that your holes are pretty much straight with a drill press and you can motor through holes much quicker and easier. And another time-saving step probably would have been, rather than pre-drilling with your 3mm and then moving up to the regular size drill bits, just skipping the pre-drill, and you can probably go through aluminum just fine with the full-size drill bit. And now I'm switching out to a 4.2mm drill for the threaded rail holes. Despite using combo drill and taps for tapping the holes, I like to drill the hole out to the same size as the drill portion of the combo drill and tap to keep the wear as low as possible for as long as possible on those pieces. Now by here I've switched up to a 6.5mm drill for drilling the through holes to mount the Z plate to the X roller tubes. And you can tell this bit's a bit chowdered up from drilling through a bunch of steel. Right as the bit starts engaging on a hole, it just throws out some really small chips and kind of wiggles around, but I throw quite a bit of force on the drill press to really keep the cutting head engaged through the material, and then you can see it really spits out those nice long continuous pieces. And this is kind of like an illustration of a good feed and speed. Sometimes you need to push a cutting surface through the material faster to get longer life and minimize heat buildup on the tool. And now I'm switching up to tapping the M5 threaded holes for mounting the rail to the Z plate. I add a little bit of cutting fluid onto the combo drill and tap, and then go forwards and backwards a little bit through the hole, putting a little bit of force on the drill there to make sure the threads don't have too much force on them, trying to pull through the material. And switching forwards and backwards is for breaking the tap piece buildup, so you don't have a bind and mess up the tool there. That green drill 3D printed drill guide's also highly recommended. I went through quite a few holes, wondering if the drill's a little bit straight, and some didn't come out too straight, but having that nice visual guide there is really good for making sure that the hole ends up being as straight as possible into the material, straight and square as possible. It's not really a good way of forcing the drill to go straight, but it's a good visual reference to make sure that you're not way too far off angle or whatever. I'll put a link in the video description to the Thingiverse page where I got these models from. It's originally designed for the DeWalt drill, but any kind of drill with a relatively clean and flat chuck collar will be able to have the design adapted to it, and it's parametric, so you can print out a little circular test piece, make sure that things fit snugly, and then print off the rest of the top and bottom pieces. And now we're going to be removing those burrs that were generated from the tapping procedure. We don't want to have any sort of non-flat buildup of material under the rails there that might push it out of square. So I find that going kind of fast and adding a little bit of a rocking motion in a circular manner really kind of helps get those burrs out. But I still need to figure out a way to clean the threads out afterwards, because especially oily tapped threads, some of those chips stick around in there, and that makes it kind of crunchy to try and thread a screw in there. Compressed air helps. It doesn't seem to get quite everything out there though. So if you made it this far, thanks for watching. If you haven't already, please subscribe for more videos on the PrintNC, and leave a comment if this more detailed commentary was at all helpful or illuminating for you. See you in the next one.